Hello, this is Dr. Christy Patton Lukes, and this is exam 3 for Thermo 1, and this is our solution for that exam. All right, so let's look at question 8. Ammonia is compressed by an adiabatic compressor, so it's adiabatic, Q is equal to 0, from 100 kilopascals and 20 degrees C. So this is my inlet conditions, and I have a data table here. So 20 degrees C means it's one of these two, and 100 kilopascals is 0.1 megapascals. So this is my inlet state, and it's being compressed to a pressure of 500 kilopascals. So 500 kilopascals is 0.5 megapascals. So one of these is my exit state. If the isentropic efficiency is given as 80%, okay, so I want to find the power input for the actual compressor and the exit enthalpy of the air. So not the ideal, but actually what is the exit enthalpy of the air. So the key thing here, and the reason this is one way of talking about the process efficiency, is that process efficiency can be based on isothermal or isentropic ideal, and it's an isentropic ideal. If it's adiabatic plus reversible, then that means that delta S equals 0. And so S at the inlet is 6.2826, which tells me that S at the exit has to be 6.2826. Therefore, this is the ideal exit state. Now, that doesn't tell me what the actual exit state is. It tells me what the ideal is. But I have the isentropic efficiency to help me with this. All right, so if I look at the first law and I assume that Q is 0 and the kinetic and potential energy changes are minimal, then work is going to be the delta H. And so delta H, if this is my ideal exit state, this is my inlet state, H is the enthalpy, then this is 1791.6 minus 1519.1 kilojoules per kilogram. And so ideal work is 272.5 kilojoules per kilogram. The actual work, and this is the ideal, the actual work is going to be found by taking that ideal amount of work and dividing by the process efficiency, because for pumps and compressors, you divide. And so 340.625 kilojoules per kilogram is the work for the actual compressor. Now this asks for the power. Power, W dot, is the mass flow rate times W, which in this case, 0.2 kilograms per second times the 340 gets me 68.125 kilowatts. So that's the answer to part A. What about for part B? Well, for part B, I'm going to still use that definition of the efficiency. It's going to be the ideal work divided by the actual work, or 272.5 kilojoules per kilogram over the actual exit enthalpy minus 1519.1. You can do this, or you can just simply recognize that W actual is the actual exit minus the inlet. In either case, when you plug numbers in, you're going to end up with 1519.1 plus the actual work, 340.625, getting me the answer 18 59.7 kilojoules per kilogram. So this concludes this solution to exam 3. Thank you very much for your time.